Today we will continue Rutherford scattering. We today derive the expression of relation between impact parameter B and scattering angle theta. Let us see that if the charge of the nucleus is Ze and 2 is the charge of incident alpha particle, then Coulomb force is given by this equation. F is equals to this one, 2 kZe square upon r square. Now here is the nucleus and this is incident alpha particle, and this alpha particle is moving along a straight line with a momentum p1. When this alpha particle is far away from the nucleus, then its momentum will be taken as p1. If the perpendicular distance of its path from the direction of direct impact is equal to b, and this b is called impact parameter. When this alpha particle comes near the nucleus, due to the interaction between alpha particle and nucleus, it is deviated from its linear path and follow this path. In this way, its momentum will be changed to P2. The angle between initial and final direction of alpha particle is theta, which is called scattering angle. If in the absence of this nucleus, the alpha particle would have followed this path, but here is the nucleus, so due to interaction this nucleus, the alpha particle got deviated from its path, and the deviation angle, which means the theta, is called scattering angle. Therefore, initial and final kinetic energy of alpha particle will be same, but momentum will change because the velocity will be changed due to the interaction with alpha particle. The change in momentum is given by this one, delta p is equal to p2 minus p1. This can be shown from this equation. If this is the p1 and this is p2, then the resultant delta p can be written as delta p. So p2 is equals to p1 plus delta p. So delta p is equals to p2 minus p1. The magnitude of delta p vector is given by this p1 square plus p2 minus 2p1 p2 cos of theta. Since p1 and p2, the magnitude of p1 and p2 will be mv, since before and after scattering the magnitude of momentum must be same. Now after solving this equation, we can write finally delta p is equals to 2mv sin theta by 2. Due to this momentum change, the alpha particle feels impulse, which is called f dt. We all know that the rate of change of momentum is given by the force, which is called f dt. Integration is equals to delta p. This can be written as this. Now from this figure, this is impact parameter B, and this is the resultant magnetic resultant angular momentum, and this one at any time this one is the position of alpha particle, so this is called Coulomb force. Its component in delta p direction is called F cos theta. So if we take its magnitude, then we can write it as delta p is equals to F dt, and F vector is equal to F cos theta because we have taken its component in delta p direction, and this is the limit minus infinity to plus infinity. Here dt can be written as like this by dividing d phi and multiplying d phi. Here this can be replaced by its value to mv sin theta. We have previously derived this equation, so we can put it here directly. F cos theta, F is the Coulomb force between nucleus and alpha particle. So this can be written as like this, 2kz square upon r square from equation first. The limit minus infinity to plus infinity. Minus infinity means the value of theta, minimum value, which means there is two cases. One is when impact parameter is 0. In this case, the alpha particle will scatter back from the nucleus if b is 0, and maximum in this case where the impact of interaction with nucleus is 0, which means maximum value of theta. In this case, from this figure we can write it as pi by 2 minus theta by 2. This is the angle, which means this angle, and this can be taken as minus infinity, pi by 2 minus theta by 2, and which is left to the nucleus, and plus infinity we can write it as pi by 2 minus theta by 2. Here in this whole process, the angular momentum conservation law will be followed. So m omega r square is equals to mvb. Here mvb is the momentum, angular momentum, which is for impact parameter, and this one is for any length, which means r, here anywhere in the direction. Angular velocity can be written as omega is equals to vb upon r square, and this can be written as change in angular velocity. So here is d phi upon dt and here is dt upon d phi, so we can reverse it. So 2mv sin theta by 2 is equals to 2kz square r squared, and this one is equals to 1 upon omega, so this can be written as r square upon vb, and this limit can be written it as like this, and cos phi. After solving this one, we can directly write it as 2 cos theta by 2. After solving it, we finally got the equation of B, which is impact parameter, and this is equals to kz square upon E cot theta by 2, where E is kinetic energy of alpha particle, which is half mv square. From this equation, if B increases, then scattering angle will be decreased, so the impact of the interaction with nucleus will be less, and if B is equal to 0, then the alpha particle will strike directly nucleus and will scatter back from the nucleus.